Imagine this, a celestial ballet, a cosmic dance of epic proportions. The sun, our life-giving star, slowly disappears from view. Day turns to twilight. An ethereal glow surrounds the darkened sun. This is a solar eclipse, a breathtaking phenomenon that has captivated humanity for millennia. A solar eclipse occurs when the moon passes between the sun and Earth. This alignment casts a shadow on our planet, creating a celestial spectacle that is both awe-inspiring and scientifically significant. Throughout history, solar eclipses have been met with a mixture of fear and wonder. Ancient civilizations often interpreted them as omens or signs from the gods. Today we understand the science behind these events. Yet the sight of a total solar eclipse still evokes a sense of awe and mystery. It reminds us of the vastness of the cosmos and our place within it. In the next sections, we'll delve deeper into the mechanics of solar eclipses, explore their cultural significance, and discuss how to safely observe these celestial wonders. Join me on this journey of discovery as we unravel the secrets of the sun and its dance with the moon. Not all solar eclipses are created equal. There are three main types, each with its unique characteristics and visual impact: total, partial, and annular. A total solar eclipse is the most dramatic of the three. During a total solar eclipse, the moon completely covers the sun's disk. This allows the sun's outer atmosphere, called the corona, to become visible to the naked eye. The corona appears as a shimmering halo of light around the darkened sun, a truly breathtaking sight. A partial solar eclipse occurs when the moon only partially obscures the sun's disk. This type of eclipse is more common than a total solar eclipse. During a partial solar eclipse, the sun appears as a crescent shape in the sky. The amount of the sun's disk that is covered by the moon varies depending on the observer's location. An annular solar eclipse is a special type of partial eclipse. It occurs when the moon is at its farthest point from Earth in its elliptical orbit. Because the moon appears smaller at this distance, it doesn't completely cover the sun's disk. Instead, a bright ring of sunlight remains visible around the moon's silhouette. This ring is known as the Ring of Fire. The different types of solar eclipses are a result of the moon's elliptical orbit around Earth and the geometry of Earth-Sun-Moon alignment. The moon's orbit is not perfectly circular. This means that the distance between the moon and Earth varies slightly throughout the month. When the moon is closer to Earth, it appears larger in the sky and is more likely to completely cover the sun's disk during an eclipse, resulting in a total solar eclipse. When the moon is farther from Earth, it appears smaller and may not completely cover the sun. This results in an annular or partial solar eclipse. The alignment of the Earth, Moon, and Sun is also crucial for an eclipse to occur. The Moon and the Sun must be perfectly aligned with Earth for the Moon's shadow to fall on our planet. This alignment doesn't happen every month because the Moon's orbit is tilted with respect to Earth's orbit around the Sun. As the Moon passes between the Sun and Earth, it casts two types of shadows: the umbra and the penumbra. The umbra is the darkest part of the moon's shadow, where the sun is completely blocked. Observers within the umbra experience a total solar eclipse. The penumbra is a lighter outer shadow where the sun is only partially obscured. Observers within the penumbra experience a partial solar eclipse. For centuries, solar eclipses have been a source of both wonder and fear. Ancient civilizations, lacking the scientific understanding of these celestial events, often attributed eclipses to supernatural causes. They developed myths and legends to explain the sudden disappearance of the sun. In many cultures, eclipses were seen as omens of bad luck, disasters, or the wrath of the gods. Ancient Chinese astronomers, for example, believed that a celestial dragon was devouring the sun during an eclipse. They would bang drums and gongs to scare the dragon away and restore light to the world. Similarly, in ancient Greece, eclipses were associated with the myth of Helios, the sun god, whose chariot was believed to be attacked by a giant serpent. These myths and legends, though rooted in superstition, reflect the profound impact that solar eclipses had on early civilizations. They highlight the human need to make sense of the unknown and the power of celestial events to shape our beliefs and cultural practices. Despite the advancement of science, the sight of a total solar eclipse still evokes a sense of awe and mystery, a reminder of the vastness and wonder of the cosmos. solar eclipses have left an indelible mark on human culture, inspiring countless myths, legends, and artistic expressions across the globe. In ancient China, eclipses were seen as celestial battles between the sun and a mythical dragon. The Chinese word for eclipse literally means to eat. This reflects the belief that a dragon was devouring the sun during an eclipse. To this day, Chinese astronomers refer to eclipses using the term shi, which means to disappear or to be hidden. This ancient belief, though now understood to be scientifically inaccurate, highlights the profound impact that eclipses had on early civilizations. In Hindu mythology, the demon Rahu is said to swallow the sun during an eclipse, causing darkness to fall upon the world. Rahu's eternal chase of the sun and moon is a metaphor for the continuous cycle of eclipses. This story is still recounted in India and other parts of Southeast Asia. It reflects the enduring influence of celestial events on human storytelling and cultural traditions. From ancient myths to modern literature and art, solar eclipses continue to captivate our imaginations and remind us of the interconnectedness of the cosmos and human culture. Beyond their cultural and historical significance, solar eclipses have played a crucial role in advancing our understanding of the universe. They have provided scientists with unique opportunities to study the sun's corona, a region of superheated plasma that is otherwise difficult to observe. During a total solar eclipse, when the moon completely blocks the sun's bright disk, the corona becomes visible as a shimmering halo of light. This allows astronomers to study the corona's temperature, composition, and magnetic fields in detail. These observations have been instrumental in understanding the sun's behavior and its influence on space weather. Solar eclipses have also been crucial for testing and validating Einstein's theory of general relativity. This theory, published in 1915, revolutionized our understanding of gravity. It predicted that massive objects, like the sun, could bend the path of light. This bending of light, known as gravitational lensing, was observed for the first time during a total solar eclipse in 1919. In 1919, a team of British astronomers led by Sir Arthur Eddington set out on an expedition to observe a total solar eclipse. Their goal was to test a prediction made by Albert Einstein's theory of general relativity, that gravity could bend the path of light. According to Einstein's theory, the sun's massive gravitational field should warp the space-time around it. This warping would cause light from distant stars passing near the sun to appear slightly shifted from their normal positions. The 1919 eclipse provided a unique opportunity to test this prediction. During totality, when the sun's bright disk was completely blocked by the moon, the astronomers could observe the positions of stars that appeared close to the sun's limb. By comparing these positions to their positions when the sun was not in the vicinity, they could measure any apparent shift caused by gravitational lensing. The results of the expedition were a resounding confirmation of Einstein's theory. The observed shift in the positions of the stars matched Einstein's predictions with remarkable accuracy. This confirmation made headlines around the world, catapulting Einstein to international fame and revolutionizing our understanding of gravity. Chasing the eclipse, a global pursuit. The scientific significance of solar eclipses, coupled with their breathtaking beauty, has turned eclipse chasing into a global pursuit. Scientists and amateur astronomers alike travel to remote corners of the world to witness and study these celestial spectacles. Eclipse chasers plan their trips years in advance, meticulously studying eclipse paths and weather patterns to maximize their chances of experiencing totality. The path of totality, where the sun is completely eclipsed, can stretch across vast distances, crossing continents and oceans. This makes eclipse chasing a challenging but rewarding endeavor. These dedicated individuals often brave harsh conditions, from scorching deserts to icy landscapes, to witness a few precious minutes of totality. The camaraderie among eclipse chasers is legendary. They share their knowledge, equipment, and passion for these celestial events, creating a global community united by their love for the cosmos. For many, chasing eclipses is more than just a hobby. It's a transformative experience that deepens their connection to the universe and inspires a sense of awe and wonder. Observing eclipses safely. While solar eclipses are breathtaking events, it's crucial to observe them safely. Looking directly at the sun, even during an eclipse, can cause serious eye damage, including permanent blindness. This is because the sun's intense radiation can damage the retina, the light-sensitive tissue at the back of the eye. Never look directly at the sun with the naked eye, sunglasses, or through unfiltered telescopes or binoculars. These methods do not provide adequate protection from the sun's harmful rays. The only safe way to look directly at the sun during an eclipse is by using special-purpose solar filters, such as eclipse glasses or solar viewers. These filters are designed to block out most of the sun's harmful radiation, allowing you to safely observe the eclipse. Make sure to use certified solar viewers that meet the ISO 12312 international safety standard. Check for any damage, such as scratches or holes, before using them. Essential tips for eclipse viewing. To make the most of your eclipse viewing experience, here are some essential tips to keep in mind. 1. Plan ahead. Check the date, time, and path of totality for the eclipse you want to observe. Research safe viewing locations and make necessary travel arrangements in advance. 2. Protect your eyes. Always use certified solar viewers or eclipse glasses to look directly at the sun, even during partial phases of the eclipse. Never use regular sunglasses, unfiltered telescopes, or binoculars. 3. Supervise children. Children are especially vulnerable to eye damage from the sun. Supervise them closely and ensure they wear proper eye protection throughout the eclipse. 4. Be aware of your surroundings. Choose a safe viewing location away from traffic and crowds. Be mindful of potential hazards such as uneven terrain or obstacles. 5. Enjoy the experience. Relax, observe the celestial spectacle, and appreciate the wonder of this rare event. Conclusion: the enduring allure of eclipses. Solar eclipses, with their celestial ballet and fleeting moments of totality, continue to captivate and inspire us. They remind us of the vastness of the cosmos, the power of nature, and our place within the grand scheme of the universe. From ancient myths to modern scientific discoveries, eclipses have shaped our understanding of the sun, the moon, and our place in the cosmos. As we continue to explore the universe, unraveling its mysteries and seeking answers to fundamental questions, these celestial events serve as a reminder of the beauty and wonder that lie beyond our world. They invite us to look up, to observe, and to marvel at the intricate workings of the cosmos. So, the next time you have the opportunity to witness a solar eclipse, remember to do so safely and with a sense of wonder. Let the experience inspire you to learn more about the universe and our place within it.